like it means nothing.
Good evening, Helsinki. How are we doing? Great. Okay, so few words about me. So my name is Dr. Nestori Syynimaa. I go with the tag name Dr. Azure AD, so you can follow me on Twitter and or X or whatever that's called nowadays, and also other social apps. And I work for Microsoft nowadays. I've been there a little over a year, and I'm a principal identity security researcher. So I have a kind of like a academic background. So I have one PhD for now, and then I have 2 master's degrees. And I also have some certifications. So it's like 135 centimeters. And the first one is from 2001. But yeah, I'm old guy, grandfather for 3 and so on. But yeah, I also created a toolkit called OAuth Internals. Who has heard about that? Nice, okay, I have some stickers, so please come to see me after the talk. And yeah, so this is technically my second time here. I just couldn't make it last time, because 2 years ago I was accepted, but I had a hip surgery the day before, so I couldn't make it. I used to do a lot of running, so whenever I went to a conference, I used to run. So this is from RAC conference from San Francisco. So I took an Uber and told him that take me to the other end of the Golden Gate Bridge, and then I ran back to the city center. And now it's okay, so I can run again. I still have put some weight. But anyways, this is from November, from New Orleans. I did run there, and even this morning I ran there before this whole thing started. And it's nice to be in Finland. I talk a lot of things in the US, but we have a different kind of measurement, so it's a bit difficult. So I told them that I used to run a lot. I even changed the distances to miles because they don't do kilometers, but they didn't understand the calories. So I changed that to Big Macs. So they understood that much better. Okay, and then to the actual agenda. So a short introduction, so what I'm going to talk about. Then I'm going to present to you some federated authentication methods. Then I'm going to talk about token-based authentication attacks, and then detection and prevention. So let's move forward. So introduction. So what we are talking about. So this is how HTTP works. So you have a client who wants to access some resource. So it goes there and says, hey, give me something. Now, if you are not authenticated, the server says to you that, hey, please do authenticate. So it's adding a header that says www-authenticate, and then it says what scheme I support. So please use one of these to authenticate yourself. And then we do that. And then if the server is happy, it gives you something back. And we are gonna, so after the first authentication, you usually are using some session cookies so that you don't need to authenticate all the time. And here are some schemes that you can use. Who remembers basic scheme? That was the good one. So your username and password encrypted with base64. And then there's some others, but we are going to talk about this authorization stuff here. So that's the point of the talk. Okay, key concepts. So 3 roles I'm going to use during the talk. So we have a user who is consuming services. We have a service provider who is, well, providing services. And then we have identity provider, or IDP, which provides identity and access management services. And yeah, and these are roles. Again, so one party can have all roles, or just 2 of them, or just 1 maybe. But these are roles. So back in the days, we used so-called silo model, which means that you had a service that had both IDP and service provider roles, and you had to use same user, you had one username and password for each service. Usually you use the same password for all the services. But anyways, so you authenticated and you got the service, but you had to trust that provider. Maybe they were using some hashing to store your password, hopefully, but as we have learned, they didn't do that anytime, well, every time. And also, like, back in the days, there were no HTTPS, just HTTP, which means plain text stuff. But anyway, you had services, and they provided both roles, services and then identity. But then came federated model, also known as single sign-on, which means that you authenticate to IDP, and when you authenticate there, you will get some kind of token. And with that token, you go to the service provider, and then you consume services. So this is like a single sign-on model. And this is based on cryptographic trust. I'm going to talk about a little bit more about that in a minute. But yeah, so cryptographically, the token is somehow trusted by these service providers. And this is a good thing. So basically, now your credentials are not going through the internet. So the identity provider could be like your own ADSS server in your on-prem. So the only thing that goes out your organization is the token. So that's much safer, hopefully. So I'm going to give 3 examples of authentication methods, federated authentication methods, and let's start with Kerberos. Who knows Kerberos? Everybody knows Kerberos, yes. So how this works. You, as a user, well, technically your client or computer, goes to identity provider, which in this case is your Active Directory or KDC services running on that box. But anyways, you give your username and password, for instance, or certificate. And what you get back is a ticket granting ticket. And now if you want to use a service, you go back to the IDP and say, hey, I want to use this service. Then you will get back service token, and then with that token you can consume services of that service. And it could be anything. It could be like internal web server or file server or whatever. But this is how it goes. So what is inside the message or the service token that is sent to the service provider? So there's a lot of things, but the main point here is that the information here is encrypted using server secret, so server's password. And how this works is that because the identity provider, your domain controller in this case, it knows all the secrets, even the server's secret. So it can encrypt stuff using that secret, send it to you. You can't see what's inside that. It's just an opaque blob for you. So when you send that to server, they can decrypt that because they know their own password. So this is how it works. OK. Next one. Sorry. So who does remember when this Kerberos came out first time? 1989. So it's an old one. But then somebody invented internet. So then we needed something else that could go through the internet, and then came SAML, or Security Asset Markup Language, and that came in 2002. So that's younger than my oldest certification. So how this works? So you try to consume service, and service says, OK, you are not authenticated. Please go to IDP, and again, you prove your identity somehow. What you get back is a SAML token. And then with that, you go and consume the service. Now, what is inside that SAML token? There's 2 different flows here. So we have the service provider initiated flow, which is the normal one. So you try to access service, and it's denied, and you are redirected to the IDP. And then we have identity provider initiated. And if you remember golden SAML attacks, so that's kind of what made it possible. So what's inside the SAML message? So it's an XML file. Who remembers XML? Who knows XML? Yeah. I like that more than JSON because, well, I'm weird. OK. So what's inside that is a XML like a document, and it has different parts, and one of them is assertion. And you have attribute statement, which says who you are, which group you are a member of, and so on. Whatever you want to put in there. Then we have authentication statement, which says which method you use to sign in. And finally, we have a signature, which is signed with IDP's private key. And that's the cryptographic trust here. Now, the service provider has the public key, so it can verify that this trusted IDP created this SAML token. Okay, then towards my specialty, which is Entra ID, or Azure AD used to be. So how OAuth thing works. So we go, OAuth was invented on when? I think it was 2007 or something like that. I'm not sure about that. But anyway, you go to IDP and you prove your identity. You say that, okay, I'm using this client, like for instance Outlook. I want to access this resource, like Exchange Online, and here's my proof of identity. Please give me access token. And it gives you access token and refresh token. A refresh token is, access token is valid for 1 hour typically. It can be more, but usually 1 hour. And you use refresh token to get a new access token. So it's pretty much same as the ticket granting ticket with Kerberos. So you don't need to authenticate all the time. And then you can consume the service. So that's how this very simple way how this works. Okay, with Entra ID, we are using JSON Web Signature. It's a kind of JSON Web token as an access token. So it doesn't have to be this format, but we are using that now. And it's used in both for access tokens and ID tokens. And it has 3 parts. So first we have which I called Jose header, which says that, okay, I use this key to sign this using this protocol. So it says what is used here. And the second one is a payload, which is a set of claims, which is again same way as in SAML, in attribute statement. This has information about who you are. Okay, it can have user information. It may have a device information. It has client and resource, so you know that where you can use this token. And then we have signature. So again, using IDP secret key, which means that, again, the service provider can use the public key to verify that this is signed with the correct party. Okay, but things are not that easy always. So the simple flow is for public application, what we call public, like Outlook client or Teams client. But if you have your own application, you also need to prove the identity of that application or client. So this goes a little bit different. So you first go to IDP, and then you will get back a authorization code. And with that, you go to the service provider, and now the service provider now needs to prove the identity of the service or client or application. And usually that's like a certificate. And then, and only then, you get back the access token, which you can then use to consume services. So a little bit more complicated. Let's continue. Next one is like hybrid authentication flow. So with Entra, you can trust other parties to do the authentication part. For instance, it could be your on-prem ADFS server if you are using that. So now it goes like this. So you attempt to consume service, which in this case is Entra ID, and it says that please go to identity provider. It goes there, and what comes back is a proof of identity of the user. And it could be like SAML token, or it could be ID token. It depends on how you federate your authentication. Then you have the stuff to send to Entra ID. Again, SAML token, ID token, whatever you are using. And then you will get the tokens. Okay, so summary. It was 2007. I remember that correctly. Good for me. So we have 3 methods. So we have the Kerberos, we have SAML and OAuth. And the format is different. So the first one is ASN1. So it's binary. And then we have XML. And we are using JWS here. And we have different trusts here. Okay, then to the funny part, attacks. Okay? So, why this is important? Those access tokens are called bearer tokens, which means something that proves who you are. So this is a bearer token, wristband, right? So it allows you to come in. And how did you get that? You had to use a QR code, right? So that's like your proof of identity. It's not that strong. But maybe what they have demanded, like to use passwords to get that, it would have been like more safe, if you will, or more strong method of authentication. But anyway, you still have this. And if somebody steals this from your hand, they can come in here, regardless what you had to use to prove your identity, because this is used as a bearer token. Okay? So with Entra ID, we have made it quite difficult to authenticate as other users. We have MFA and conditional access policy and that kind of stuff. So it's very hard. But that happens before you get the token. And if you have the token, you can be that person. You can use same services as the token lets you do. For instance, I have a speaker badge, so I can go to backstage. You can, unless you steal this. Okay? So, I made a graph about attacks. So we have like 2 lanes, if you will. So if you are very skillful or you are APT, you can steal the secrets, token signing secrets, and then you can forge your tokens and use them. Okay? But if you can't, you may access users' devices, for instance, and you can steal an existing token and then use that. Does it make any sense? Okay. So, my attack techniques, I'm just going to leave it here for a few seconds, so if you want to study those more. But basically, those are the techniques you are using. And then we have profit. Okay. Realms. So this is like how I think about this. So we have 2 realms. So we have endpoints where all the stealing happens. Okay. So you either steal those tokens and secrets or tokens. And then you use them outside the endpoint, which I call here cloud in quotes, because it just means everything that is outside our hands. So we can defend those endpoints because we own those. But what happens outside of those, we can't do anything. So that's what this kind of tries to tell you. Okay, then add the roles. So users, you steal tokens from users, you steal secrets from IDPs, and you use them with service providers. So again, those 3 same roles. So at Microsoft, we have seen a lot of ways to do stuff, but mostly use things to steal tokens. There are two ways to do that. First is quite often used adversary in the middle, which means that you usually authenticate yourself to Entra ID, but sometimes you, through phishing, you will get a link that looks like Entra ID, but it isn't, and it goes to evil things or some other thing. And what happens here, it's a proxying you what the correct Entra ID login page look like, and they can intercept your username and password, they can intercept the tokens that are coming back. So whenever you are logging in through that, for you it looks like I just logged in. But then the attacker was able to get your tokens and also your credentials. And even MFA doesn't help here because you will get the tokens that are coming back. The second one is that you can install a malware on users' endpoints, and then you can steal tokens from there, and other stuff too. So what can you steal from users' endpoint? So there's a lot of things. So first of all, there are keys that provide, prove the identity of the device, but that requires that you have local admin permissions and that the computer doesn't have TPM. So that doesn't work that well. But other things that you can steal authentication cookies, which are Entra ID single sign-on cookies, and they may be valid like an hour, or they may even survive like reboot. So it depends, is it a persistent one or not. Then you can have a thing called PRT cookie. PRT stands for primary reference token. and then you can have a token. And for three of these, you only need to have users permission. Also with adversary in the middle attack, you can collect those bottom three. Okay, so what kind of tokens we have? Another pyramid. So the first one is primary refresh token, which proves identity of the user and the device. And also like which method you used to log in, so it could have MFA and that kind of stuff. That requires that you have local admin permissions and you know user's password or PIN code. And if you have that, you can then get access to any resource or service as any client that the user have permissions to access. Then we have refresh tokens and then the actual access tokens. And the lifetime here is a little bit different. So for primary refresh token, it's 90 days. Refresh tokens, 90 days. And for access tokens, it's typically 1 hour. But if you are using thing called conditional access evaluation, it can be up to 28 hours. OK. Who wants to see demos? Woohoo! OK. So I have a special demos for this talk. So let's meet our bad guys. So on the left, we have a legacy byte. Write cell code with hexa editor, can spawn calculators, and has limited resources. Then the other one, Cloud Enigma, lives in parent cellar, knows how the fuck the cloud works, and then only has a small allowance, but, well, cloud is cheap. OK, so let's see how the story goes. So I got access to ADFS server. OK? So can you get me token signing certificates? Why? So that I can forge SAML tokens. Why? So I can log in as any user I want to. So let's see how this works. And here we are. We are on ADFS server, and I loaded my toolkit. Well, actually, there's now two parts. So one is AAD internals, which is meant for cloud-only stuff. And then we have AAD internals for endpoints that is used for endpoints. OK? So let's steal the token signing certificates. So get AAD int ADFS. No. Export. So I'm running one command, and it should export the certificates. If that works. Oh, it did. So now we actually have token encryption and signing, but we only need the signing one. So I can actually see that far. Which one is which? The longer one is encryption, so this must be signing. OK. Then we open that up. And it should say ADFS something. So I just copy this one. Then I go to hacker's laptop. So this is a different server. I just paste it there. Then I have a script here that I'm just going to run that. And it used that SAML token, connect it to Entra ID, and get back access token. And if we go here, we can see that it used MFA, even though I didn't. And the reason for that is that, well, I can show it to you. So st set content token.xml. And the best XML editor is, by the way, is Internet Explorer. So as you can see, so why we had MFA? So if you have a token sign-in key, you can create a token and put anything in there you want to. And Entra ID has a feature that allows you to bypass MFA by saying that authentication references has multiple authentications. So you just add there and you bypass MFA. Of course, there are settings that you can use that prevents that, but by default, it's how it works. And by the way, Entra ID doesn't care about what is the user principal name here. So it's always joulupukki@korvatunturi.fi when you're using this toolkit. It only uses immutable ID, which is basically users base64 encoded on-prem AD GUID. Okay? And it was actually funny when I joined Microsoft. People asked for me that in Microsoft that, what does that mean? That joulupukki@korvatunturi.fi. So I said it means Santa Claus at northpole.com. But yeah. Okay. So that's how you can steal secrets. So in this case, we had a hybrid organization. We were using federated identity, and we were able to steal the token signing certificate and key. Okay, then stealing tokens. So I got access to organization's global admin laptop. So can you get me PRT and session key? PRT as a primary reference token and session key. Why? So that I can log in as a global admin. What about MFA and conditional access policies? Because we probably are going to demand that you are logging in from a managed device that is compliant with MFA. No problemo. So let's see how this goes. So we move to the laptop. Okay, so I need to be local admin. I need to know users' username and password. But if we have installed malware on that box, we do know those things, right? And I have saved the credentials to a variable. So we are Diego at Cantoso, that Azure Labs Online. And now we want to get the PRT and the session key, which is required to use the PRT. And it doesn't matter that do you have TPM or not, they are cached in the disk anyways. But let's just say settings equal get AD int local. No. User PRT keys from cloud AP cache. Okay, so now I should have the keys in the JSON file, but also in that variable. So it looks like this. Okay, but let's just copy that to clipboard. So convert that to JSON and then set clipboard. Then I go back to the hacker box. Here, let's just close that down. Then the settings equals get clipboard, convert from JSON. So now we should have the same settings here, yes. Okay, so now that you have the PRT and you have the session key, you can create things called PRT token. PRT token. Okay, there's too many T's there. Equals new AD int user PRT token. I provide the settings. And now using the PRT token and the session key, which in those settings, it created a PRT token. So it signed that. Well, we can actually look what's inside that. And come on. Okay, I can paste it here. And what we can see here is that it has the reference token. And pretty much that's it. So the PRT token is where that is used. So when you are logged into your Entra ID joined computer and you go to, let's say, Teams or whatever using browser, it automatically creates this, and it's adding that to a request header called XMS something. I can't remember the end of it. But anyways, this proves your identity and your device's identity. And let's try to get an access token. Access token for, let's say, Teams. I provide the PRT token, and then it gets you an access token. Okay, and now I go back here, so I have to space it here, and now we can see what kind of access token we were able to acquire. So if we go here, we can see that, where it is, here, oh, AMR, here. So it says that we used password, RSA, and MFA, which we didn't. We used that when we were acquiring that PRT that was saved on the cache file, okay? And then when I go more down, I should have device ID. So because this was stolen from a device, which ID is that, and it's compliant, we can like pretend to be that device. So that's why this PRT is very powerful. So that's what people quite often want to steal. Okay, so how to prevent that? But let's start with detection. So we have certain sources where we can detect stuff. So we have the IDP. So logs of that IDP bug. So if it's your ADFS server, it's the log events, Windows log events in your server or MDE or whatever you are using to monitor that. And then for users, you will have things happening in your user endpoints, which are logged there, and also like, again, if you are using MDE or something like that. And then in the service provider side, you need to have IDP side logs for signing events, and also events that how tokens were used in your service. I'll try to explain and show that to you also quite often, so soon. So, first scenario, you have your on-prem web server that is using Kerberos. So you have your logon events in your on-prem Active Directory, and then you have also events in your on-prem server. Now, if there are some events happening here, but there's no corresponding signing event or logon event on your AD, it means that somebody has stolen the secret of your server. Okay? Hybrid identity. So what we did here, so we stole the token signing certificate, okay, and we created our own SAML tokens. So now there are, in Entra ID, there's a signing entry, but there's no corresponding event on ADFS, nor in your on-prem AD. So that's how you can detect that. The theft of your token signing key. Okay. Then an example that you are using a cloud-only identity. So you have Entra ID, you have signing logs, then you have your own usage logs. So whenever you will get a token, you should log the content of the token, or at least the metadata. And the most important is unique token identifier, or UTI. So that should match. Now, if somebody, well, this detection detects that if somebody steals key from us, but that has never happened, right? So I don't know if that's that important, but let's see a demo about this. So I created an Azure web app. I try to access that. It says that please go to authenticate yourself. You go authenticate. There will be an event in signing logs. And then you can go to application, then you will have event in usage logs. So let's see how that looks like. So I'm going to Azure. Okay. So the first log here is, it's an hour, let's say 48 hours. So what do you have is, so what are you looking now? I'm in Entra ID, I'm using log analytics, and I'm showing you how you can detect stuff, what I just explained to you, with your own web app. So first you have signing logs. So these are Entra ID signing logs, so there's a lot of stuff. For instance, we can see that we logged into Microsoft Teams using our tokens, but we have also like a token test application here. The second log here is the web application logs, so I can query them too. So here are like signing events that people have used the service. So whenever there came a token, I brought that to a log. And the second one is for detecting that are there any events on my web app log that are not in signing logs. So this query will show that. It doesn't matter what the query says, the idea here is so important. And it found something, but let's change this to 48 hours, so there should be only one. And do you remember what was the important attribute? What's the unique token identifier? So let's see if I can go here, and here we can see that there's a UTI hackety hack. So that was created by somebody with the key that was stolen from us, but that's never happened to us, so don't worry about that. And the third query is that it is looking. So let's go back. So in access tokens, you will have the IP address from where the request for the token came from. Okay? And if the token IP is different inside the token and where the request came from, you know that, okay, that token was stolen, right? So this will show if there are different IP addresses where the request came and what was inside the token. And here we can see that there are like a different token IP and request IP. So this means that somebody used a stolen token. Okay. Then cloud-only identity number 2. So what if you are using like service providers like Entra ID and then Microsoft 365? So you don't have same kind of logging capabilities that when you are developing your own application, right? So you have signing log events, obviously. And then we have like unified audit log, which records that whenever some user is doing something, so if there's something that is not in signing logs, somebody has stolen our key. But as you know, that has never happened, so don't worry about that. And then you have also now Microsoft Graph API activity log, so you can see if somebody is calling API. And then again, if there's no corresponding signing event, somebody has stolen our key, which again has never happened, right? Well, actually it has. So this was from 2023. So what happened was that an organization called Storm 558, or we call it that, and just to make sure that it's China-based. Okay. So what happened? They stole a secret from us. But what is interesting is that they stole expired Microsoft account token signing key. A Microsoft account means like hotmail.com, who remembers? Yeehaw! Or outlook.com. So it's for consumer side, and it was expired, right? How they stole that, we don't know for sure. We have some suspicions, but we don't know for sure how did that happen. And then in service provider side, in this case it was Exchange Online, so there was a misconfiguration that allowed to use those tokens that was signed with an expired consumer side. So this is from Entra, which is more like enterprise side, so that shouldn't have been possible. But there was a misconfiguration, okay? Now, this shouldn't happen ever again, but it would be, my suggestion would be that even though that this event would be rare, you should have detections in place, just in case. It doesn't cost you anything more. And if something like this happens, you would see it by yourself also, quite quickly. OK, so how to prevent stuff then? How you can prevent stealing of tokens? Well, you need to harden your IDPs, whatever that is, like on-prem AD, ADFS servers, and so on. We will take care about the Entra ID, I promise you that. And then zero trust for your users. And what does that mean? It's a buzzword, I know, but what I mean about zero trust is that don't ever allow users to access your enterprise resources or assets with their own laptops, because there can be malware. I showed to you what it can do. So only devices managed by you and probably compliant also. And then if you are providing services, always verify. Verify the sign-in logs, usage logs, and also what's inside the tokens. Is it coming from the correct IP address and so on? So there are various things that you can do. And also what you can do is, so we have a thing called token protection. And what does that do? Sorry, what does that do? Okay, so this is an Entra ID joint managed device. And if I'm using token protection, and by the way, it needs supported client and service, for instance, Teams. So if I require that using conditional access policies, what happens? So when my computer gets an access token, it is using the PRT and session key to sign a kind of request, quite similar to PRT token, but it's not the same, but similar. And what comes back is a response, and the response is encrypted with the session key, which means that only your computer can open that. So even though if you are using like adversary in the middle, the attacker can intercept those tokens, but they can't encrypt those. Sorry, they can decrypt them because they don't have the required keys. So it protects against that. Then we have a thing called a continuous access evaluation, which basically means that the services which need to be supported again, like Exchange Online and SharePoint Online, they can talk to Entra ID. And Entra ID is telling them that if something has changed regarding the user, like maybe the user's password was reset and so on. So when they are trying to use the service, Exchange Online says, OK, your password was reset, so please do authenticate again. OK, so what happened to our bad guys? Oh, shit. They are hardened ADFS servers. And why? Because it's tier 0 asset. OK, so what? I can't steal token signing certificates anymore. So steal some tokens then. OK? Those mittens removed local admin permissions from users. Why? So that they can install malware even by mistake. So I can't steal tokens anymore. So go phishing then. OK, now they are using token protection. Why? So that I can't do AITM anymore. So I can't even fish tokens anymore. Oh, shit. So that was a nice story. It ended well, like in American movies. OK, so to sum up, so stealing tokens give you a temporary access as a one person. That's easier, right? Stealing token signing secrets give you persistent access as anybody. OK? Detect and prevention token test is team sport. So we need to have admins and users and service providers and so on. Even us at some time. So, and if you want to detect stuff, you need to have access to both IDP and service provider logs. So that's technically the only way that you can do that. And use token protection and continuous access evaluation. So they are not silver bullets. They prevent some stuff, but not all. And those guys weren't that happy. Usually in my talks, I don't do any like AI content, except for those two guys. But I asked from AI that, can you draw a picture of me as an old guy, shouting at clouds? So that's how it looks like.